Hi everybody, this is Tor Storley, and I am back with another video. Okay, welcome back. We're going to continue where we left off with the database and the DuckDB environment. And now we're going to start looking into the VS Code portion of this project. So what I have is I created a VS Code project, and I added a bunch of files. I've been experimenting a little bit. Some of them are trying to do extra to it, and the code may or may not work and so forth. Like you see here, what I decided to do, there's a model, a large language model that is perfect for DuckDB. It's called DuckDB-N-SQL. And it's really created by MotherDuck, I believe, and it's sitting out on Hugging Face. So Ollama also provides this model, and if you want to pull that model down, if you use Ollama, which I will be using in this video, you can see here you can do Ollama pull DuckDB-N-SQL latest, and that will, if you run that in a bash window terminal, it will download the latest. So let me show you what it looks like in the Ollama listings. So I can say Ollama list, and that will list all the models that I have downloaded into my Ollama environment. And one of them, as you can see here, is called DuckDB. So let me make that a little larger. So you can see it's DuckDB-N-SQL latest. And as you can see, it's about 3.8 gigabytes. And I did this about 3 days ago, I guess. So let me minimize this again. But you can use this Ollama list to see which models are available to you. All right, so I'm going to be working with this model here. Now, I tried some of the others. I tried this Gwen 2.5 coder. I tried CodeLlama. I tried DeepSeek. I'm trying to stay away from the really big models because they take a long time. I don't think my GPU is doing me service on these larger models, even though they're only like 7 billion parameters. And I did that. And of course, I tried this SQL Coder, both of these, but I didn't really have good feedback for them. Now, the one we're going to be using is not producing great output either. So I think it has to do with training it better, maybe providing better information, maybe. I'm not sure. So in this video, my purpose is simply showing you how you can set this up, and then it's up to you to fine-tune and try to get the best results out of these models, if you will. Okay, so I created this Jupyter notebook. It's called LLM2SQL Vanna TPC-H Iron Python or Python notebook. Okay. So the first thing we want to do is import some stuff. You know, I'm not using all of these libraries. For example, I don't think I need this OS. I'm just going to leave it for now because I know it runs. I'm going to import DuckDB, but I don't really use a DuckDB like this per se because I imported in one of the cells later. So it's not a good code. But I want to get Ollama. I want to use this through this framework called Vanna. You want to use this Qdrant Vector store database, and you also import the client for this like this. And then because I want to use a browser-based way of talking to the database, I'm going to import Flask, which comes with Vanna, by the way. You can also get the flavors of Streamlit with it, and I think there's one more choice, but let's take a quick look before we continue what this Vanna is, okay? Let's hold on for a second and let's go take a look at it. So you want to go to this website called Vanna.AI. Now, there's a very short video here that tells you about it.
Vanna, chat with your SQL database using AI. Navigating through a sea of data can be daunting, but what if you could get answers from your SQL database as easily as chatting with a colleague? Enter Vanna.AI, the revolutionary open-source Python package that's changing the game in SQL database interaction. Imagine launching an intuitive interface right from your favorite Python environment like a Jupyter notebook. With Vanna.AI, you ask your business questions and it responds not just with SQL, but with tables, charts, and in-depth follow-ups for a comprehensive analysis. It's like having a data wizard at your command. But here's where Vanna.AI truly shines. It understands the unique language of your business. By feeding Vanna your database metadata and business documentation, it grasps the nuances of your enterprise like no other. Vanna.AI doesn't just query databases, it speaks your business language. And there's more. Vanna.AI learns from the past to shape the future. When you provide examples of successful SQL queries used in previous analyses, Vanna.AI becomes even sharper. It uses retrieval augmentation, referencing this rich pool of information when collaborating with the large language model to generate SQL. The result? An astonishingly high degree of accuracy in SQL query generation, tailored to your specific business needs. It can perform as well as a data analyst if you train it like a data analyst. The flexibility of Vanna.AI is unmatched. Connect it to any SQL database. Choose any large language model for its brain, and any vector database for its memory. And with its completely free hosted options, Vanna.AI is not just powerful, it's accessible. The built-in UI is a game changer, especially for those looking to integrate a chatbot with their SQL database. The simplicity and ease of use are unmatched. Plus, for developers looking to integrate Vanna.AI into their applications, there's a wealth of resources available. Sample codes for Streamlit, Chainlit, Flask, and Slack apps are just a few clicks away on the Vanna GitHub repository. Get started today in a few lines of Python code. This has been Vanna.AI in 100 seconds.
Okay, so as you can see, that was a very fast introduction to Vanna. I'll give you that. Said it much faster than I could do. So let's go to the docs. And here you can see, if you look at the documentation here, much like he described in that video introduction, this is kind of the way it works. So you're going to have like a search where you're going to have a question, like a prompt. It will go into this framework, the Vanna.AI. It's going to look for DDL schemas. So what is that? Well, if you remember, I showed you the database that we're going to be using in DuckDB. That contains 8 tables, and any other object that are in there you can probably bring out. The DDL will be the table schemas. Then you can also add your own documentation. For example, how you want the Vanna or the vector database to think about your question or how to proceed with it. For example, you might want to say, hey, this is the key. Make sure you match that to the other table via this key combination, stuff like that. Any other documentation kind of things you want to put in there that helps solving your problem. And then you have SQL, where you can actually, remember we have 22 queries. You can actually train the Vanna framework or the vector database that sits behind it with the SQL queries. So there's like 3 ways of putting in this training here. And any vector store, the reason I use Qdrant is because I tried the other vector database that are by the default, I guess it's called ChromaDB. That's the default database. Now I'm on Windows and that didn't really work for me. I had to do a bunch of fixes to make it work and I gave up. So I switched the vector database to be this Qdrant and works very well with the Windows architecture. But as you can see, you're getting all your background, your database information here. And then you create a prompt and you pass that prompt to a large language model. In our case, it's going to be an Ollama model. It's going to be the DuckDB version of it. It's going to try to figure out what you're asking and produce a SQL query. And then it's going to try to run it if it works. If there's a problem, it will tell you, okay, you might have to do some fixing and so forth here. There's also charts and stuff like that. Now, I happen to know that in my case, the charts are going to be meaningless with this database. So I refer you to some other databases you can actually practice with, like a SQLite database or what have you. So as you can see, this is the layout. So it's going to produce and answer the questions. This is how you train the Vanna network. You can get started. You can go quick. Notice this. It's just a couple of lines of code here to get started. And this will use the SQLite database called Chinook, which is the default demo database that SQLite comes with. And as you can see, it gives you just like very, very basic stuff here. And then it also loads the Flask environment. So I want to use my own data. So I'm clicking on that, which is the second option here. Quick start with your own data. So I'm not going to be using any of these two. I'm going to have a VS project. But nice thing is that notice you just have to select what you want to use. So you can use OpenAI, and of course, they produce fairly decent results. Now I'm choosing Olama because I'm going to host my own model. You have to choose a vector database. So notice here, ChromaDB is the default, but it didn't work for me. So I choose this Qdrant, and that one seems to work in Windows okay. There are videos on YouTube you can check out using the Qdrant database, and I'll see if I can find a link for you, so if you want to inspect it a little closer. You run a pip install with Vanna, and then in brackets you put the vector database, the Qdrant. You're going to be using Olama in my case. I'm not going to use Postgres. I'm going to use DuckDB. But down here, as you can see, I want to choose DuckDB. So let's go look at the code now. So as you can see, it changed. So Vanna, square bracket, Qdrant, comma, Olama, comma, DuckDB. So you pip install those into your environment. I'm using Minicon.3. And I'm creating a virtual environment I call Vanna, and that's where I actually run this code. And then you can start bringing in stuff, and you can create a class like this. That should get you started. Very soon you can realize you need to do more. But also notice that you can train. So you train the vector database by using this VN, which is you already created object, like here. You say, this is my class. And it has this vector store. I'm going to use Olama. And my Vanna is what you call it. You're going to config the client, and then what you're going to be using and which model you're going to be using. And then you create an object like VN in this case. And once you get that, you can start playing around with it. Like you can use that object to connect to your DuckDB database, for example, like this. You can also run SQL, like you can see here, to get like the schema information, the columns in the schema. You can also run like training with this stuff. For example, you can train the DDL, which is the schema information. You can train the documentation where you add additional features in. And you can also train with SQL. So I will be using all three of those. And then you can also get the training data, so you can view it and inspect what's went into this vector database. So that's kind of what I want to do. And when you're happy, you can actually just launch Flask. So you can see it here. It creates a Flask environment for you. So if you look a little closer, it's just a couple of lines of code, and it will open up your browser. Actually, will give you a localhost link, and then you click and open it up in the browser. And this is how you can simply call it like this. So let's take a closer look and see how this will work. Well, let's open up the Visual Studio Code again, like this. I'll try to go fairly fast through this because the video will get very long if I try to explain everything that's happening here. Now, I have more advanced versions of these files. As you can see, there's a copy, there's this one. And I tried different things. One thing I wanted to do, use the original queries if the question is the same or similar. And I tried to look into this, and I haven't gotten to that point yet, but I looked into it, and the code got longer and longer. So I'm not sure if so I went back to my original, which is a minimalistic. But anyways, you can see here, this is my import statements as we went through. And here's the class. And the only difference here is that I'm creating the vector database in memory, okay? In memory. So the Qdrant config is in memory. And the nice thing about that is that it won't save your stuff. So in case you have to run it again, you just run through the code again over and over and over. Here is where I'm creating my Vanna object, my Vanna based on this class. And as you can see, I'm using this model, which is the DuckDB-NSQL latest model. That's what this code is doing. So let's just run it as we go here so we can actually be up to speed. So as you can see, it's running the import statements, and it's done. Another thing I noticed too is if you're in VS Code, some of these cells get really large, so it's kind of hard to follow. What you can do is you can just click on this blue line here, and if you click on the top here like this, it will collapse the cell, which is a little easier to read, I think. So I'm going to continue doing that, I think, like this. I'm going to run this cell, which gave me an error for whatever reason. So let's figure out why that is. Okay, I got a feeling that I have DuckDB open. And let me see if I can close it and take care of that. All right, so I ran the class here and I created this VN object, as you can see. Now, when you do this training, you don't want to do it over and over again because that will just duplicate it. So you want to run it once and that's it. I'm setting up some code here. This function is only going to extract the SQL from text. And if you remember, I had some SQL queries that are text-based in a list object. And this particular this code is going to extract out from there using regular expressions, as you can see, because I imported that above. It's going to extract out the actual query from it and build a list of queries that I'm going to be training this vector database in. So it's going to return the queries when it's done here, as you can see. So you're passing in the text, and then it's going to return a list of queries. So it returns a list of tuples, actually, where they have a query number and the SQL statement. All right, so that's the idea here. I'll show you that when we get a little closer to it. You can see what it will actually look like. Okay, so this next one is to get the schema from the DuckDB database. And I use this extract schema for Vanna function, pass in the database path, and it's going to come from the main schema in DuckDB. And as you can see, I'm going to return a dictionary containing the DDL statements and table information. So here I'm creating a connection to the database based on the path. And then I'm basically building the query string here. Well, I'm going to pass in the schema name using a F string in Python. And here I'm setting up tables that is going to contain the data, if you will, the schema data, and the table names like this. And I'm going to load it into these different parts, the DDL, the table info, and the training data. Okay, so that's a dictionary right here. And of course, this is a dictionary object, this is a list, and this is a list, as you can see. So this query here will actually build up the schema information. And once you're done with that, it's going to loop through it, as you can see. For each column is going to build up the table names, etc., etc. Now, I will make this code available for you. So I'm not going to go through every line here because it will take forever. We're already way into this video. So I'm closing and I'm returning the schema info. And you'll see here in a bit when we run this code what it will look like. Then I want to train Vanna with this schema that we're just producing. I'm going to pass in the database path, the VN object, and this is the schema name. And you can see based on these arguments here is that this is the instance of Vanna, this is the path to the database, and here's the schema main name, right? And again, it's a loop here, and it's going to build up and train the DDL, as you can see here, okay? So this is for the schema generation. So it's going to train Vanna with the DDL, okay? Now here is where I'm going to train it with the queries, and we're going to get those from those 22 queries that I showed you in part 1 of this video. I do have a list further down here, so when I actually pass in this, I pass it in here, which is a list of queries. So let me scroll down a little bit so you can get an idea. Here you can see it. This is the list that holds all these queries. And here's the text. This is query 1, and this is the actual query. So it's basically going to be passed into that function and parsed out. So each one of these queries is very, very long, as you can see. It's going to be parsed out and be returned where you're training the SQL query. And if you look at it, these are descriptors of what the actual query is doing. And I showed you this in a previous video, these descriptors. And here is just some printing statements. Here is where you actually train it. And notice this is the SQL portion of the query training. So you have the DDL that we did in the function above, and now you're going to train the SQL portion based on these SQL statements that we're parsing out from that list. And then it's going to basically run this loop and it's going to train it. It's going to train this documentation as well. So there's query description will be referring back to this portion here, and that will also be put into the documentation training. Okay. Now this cell is rather large, so let me collapse that. Now we're going to try to get some sample data. And again, you pass in the database path and you say, I only want 5 records, okay? By doing that, you get some data back and you can actually let the Vanna framework know what your data looks like. Here is the code that will actually do that, and I'll let you ponder over that. And finally then, you're getting down to the meat and potato of it all. This is the main code. So it's going to set up the database path. This is where my database lives. And it's going to start printing out, you know, okay, you're training with a schema. Now you're going to train the queries and adding business context, etc., etc., because you're going to train the documentation. These are calling these functions we just went through upstairs here. And here we are adding some additional stuff. For example, this is showing you the tables, what they represent, the key relationships. Also for documentation, notice I give you the tables, like customer relates to orders. How? Well, via the C_cust key is linking to the O_cust key between these two tables. So you give an additional information basically that will help the LLM produce a better query result. And again, here you say, hey, I'm going to connect to the database. I'm using the VN object. And then I'm going to print out some stuff. And here you can see the summary. We're going to print out how many records are in each table, etc. For example, show how many are tables, how many are SQL queries, how many are documentation inputs for this training, and so forth and so forth. So let's go up and run that again, because I haven't run this one yet. Let's do the sample data first. Okay, done. Now I'm going to run it. And this will take a longer time because it has to run through all of these different functions and produce the results. So let me still it while it's running, and then I'll come back to you and explain it. 9 minutes, 4.4 seconds. That's a long time to train this. Here you can see the printouts from this cell here. You know, I have like a bunch of information, printing out step 2, step 3, step 4, etc. So if you look at the output, you can see here is the tables. This should be 8 tables. So you have here is the 8 tables. And then you also have the actual DDL, which is the create table information that we generated in one of the functions above. And as you can see, it goes through every table and extract out the column names and the type, etc. So that's what the second part is doing. And now it cuts off because it's too much text. But you can click on this text editor. And notice over here, you can see this is the printout right here. So here's the 8 tables. And then it goes into training with the queries. And remember, we had 22 queries. So it says it found 22 queries. And here's the first one. The query number 1 was with the pricing summary report. Remember that one? And it also tells you, hey, I'm going to use Olama parameters here. I'm going to use this model. And there's some other stuff that goes through here. So there's like information about, you know, system, and the user is going to give you the SQL because it comes from that file, or actually this list, etc., etc. You can see here's some other categories. Adding the business contact. Okay, we're adding documentation. We connected to the database. And here you can see the table sizes I've been talking about. So customer table has 1.5 million rows. The line item is the biggest table. It has 59, almost 60 million rows, as you can see here. And this one has 1.5 million rows, I guess, the orders. And the parts, 2 million rows. So yeah, you can get an idea of the size of these tables. And obviously, when you put a bunch of tables together, it should take some time to query it, you know, especially if it's aggregations with order by. Here you can see the test questions that we produced, like show me the top 5 customer by total revenue. And let's see, did it produce anything at all? it produced this query. So here's the LLM response, this query. Now, it looks like it is working after it does all this training. So here you can see we can get the training data back. And as you can see, the question is this. You can see there's 6 pages. And here's the select query. And you can tell from the SQL. So as you scroll through this, you can see here's the DDL, which is the table scripts, which is the create table, as you can see. And then, of course, you have the documentation scripts as well here, as you can see. So this is a quick way of getting data back from the vector database and inspecting it. And it comes in form of a Panda data frame. All right, the final step then will be to launch Flask and see what that one will look like. Let me make sure it's not open already. All right, so we loaded that, and it tells you can log in here through this localhost 8084. So let's try that and see what it produces. And here you can see it produces some questions for us that we can run, or you can ask your own questions. And if you look at here, there's training data, new questions, etc. You can sign out here. Let's try one and see if it actually works. So it's thinking, it's running it through the DuckDB and SQL model. Now, a lot of times I notice when I try to run this stuff, it doesn't give me a good result. Or sometimes it doesn't run anything. And as you can see here, it's thinking. So let's hold off till it's done. So find top supplier by total revenue contribution between January and April 1996. And this is the query it came up with. Limit 2. So there's 2 suppliers, as you can see in the output here. And you can also download this as a CSV file. Also, it produces this plotty type of output. Now, it might get much more interesting depending on the query you're running. You can redraw the graph. You can also do some additional stuff here. You can also train question SQL pair. Now, why would that be interesting? Well, if you remember, I had these 22 queries with the description of the queries. And when I did train this, I did train it as a pair, where you have the question related to the SQL. The problem is that every time I run this now, it's going to try to generate this query. So if I have those 22 queries, and if it produces the same question that relates to the query, I would like it to just run that query without having to go through an LLM. However, in this version of my LLM to SQL, it simply doesn't work. Now, if you click on training data here, these are the SQL queries that it was trained on. So you can actually view them here. You can go to next, and you can see here's the create tables, etc. So you really have an overview of what's in that database. So that's kind of nice. Let's do one more, I guess. So let me go new question. Now, some of them work, some of them don't. So I don't know, let's find discounted maybe. Let me see what that looks like. And I'll still it and come back when it's done. All right, so you can see here, it came back and it produces some weird stuff because there is no table called revenue, as you can see. But this is the query and would allow you to do like auto fixes or manual fixes as well. Let's try the different question. Let me try this one and see what that produces. All right, so I came back with this query, and it tells me that there's some problems with it, like average yearly not found in from clause. I don't know why it's looking for that. P-type, So you can also click this auto fix, and it's going to try to adjust the query by using the suggested candidate bindings here. So let's hold off for 1 second and see what that produces. Yeah, so you're getting a lot of crap, as you can see here. And quite frankly, I'm not too thrilled with this whole thing. But I want to introduce it to you so you have an idea of what it is. And hopefully you have better results than I do. So AI has its pros and cons. It can be wonderful in many events. It can be terrible in others. And it will keep producing more and more and more code. And in the end, you're getting just drowned in potential fixes to all this code. So I have mixed reactions to working with AI, I got to tell you. Anyways, that's the video. I hope you learned something from it. If you like it, give me a like and consider subscribing to my channel. That'd be wonderful. So good luck trying to get this to work and set up your own environment. And hopefully it works better for you than it did for me. I'll see you in the next video. Thank you so much for watching.